Okay, 2 days ago we learned how to take a function and find its inverse. What were the 2 steps to finding the inverse of a function? Switch the x and the y, and what was step 2? Solve for y, get y by itself. Then yesterday we were given 2 functions and we had to state whether they were inverses of each other, which meant find the inverse of one of them, see if it looks like the other one. Today we're going to learn how to graph inverses. Okay, so they gave us our first function. We're going to graph it by using a table of values, and then we're going to graph its inverse. Okay, if they give you an equation and a table of values, how can you use these numbers? Plug them in. Okay, so pick one of your colors, and we're going to do all of this table in that one color. So if I plug in a 0, 2 times 0 minus 6 equals negative 6. If I plug in a 1, 2 times 1 minus 6 is negative 4. Okay, if I pick a 2 and plug it in, 2 times 2 minus 6 is, if I plug in a 3, 2 times 3 minus 6 is, if I plug in a 4, I get 2 times 4 minus 6, which is, and if I plug in a 5, 2 times 5 minus 6. Okay, so now we have ordered pairs, which we could plot over here as points. So how do I plot the ordered pair 0, negative 6? Okay, but what does that mean? Okay, over 0, up 6? Okay, look, your x value is 0. Right, your x value, this is your x-axis. So if your x value is 0, you do not move on the x-axis. Your y value is negative 6. So on the y-axis, you go down 6. And plot your first point. Okay, our next point is 1, negative 4. So how do we plot it? Which way over? Right 1, because it's a positive 1, and then down 4. Okay, 2, negative 2. Right 2, down 2. 3, 0. Right 3, and then that's it. 4, 2. Right 4, up 2. 5, 4. Correct. Okay, now, those points form a line. So we're going to connect that line, connect those dots with a straight line. Now, why do you think they made a line? This is a linear function. Okay, when your largest exponent is a 1, it's a linear function. Okay, anytime that you have an equation in y equals mx plus b form, it's a linear equation and it will form a straight line. Okay, so anytime you have an equation in y equals mx plus b form, meaning that your largest exponent is a 1 right there, then it's going to form a straight line. Okay, so that is the graph of 2x minus 6. Now we're going to graph the inverse of it. Well, we learned how to find the inverse of a function. What would step 1 be? Okay, this is y, this is x, so when we switch them, it would look like that. Then what would we do? Add the 6 over, add the 6 over, so we'd have x plus 6 equals 2y, and then what did we do? Divide by 2, divide both of these by 2, and so those cancel, and you end up with y equals, this is a 1, so 1/2 x plus 1. So we could also graph that for our inverse, but there's an easier way than going through all that work to get the inverse function. What's the first step to finding an inverse? Well, if you already have x's and y's, can't you just switch them? And isn't that easier than taking time to find the inverse of the function? And so now we have more points to graph. All we had to do was look at the original table switch the x and y's, and now we have the inverse functions table. Okay, so how do I plot that first point? -6, 0. 1, 2, 3, 4, 5, 6 to the left. Okay, what about -4, +1? Left 4, up 1. Okay, -2, +2. Right, left 2, up 2. 0, 3. Yeah, you're right. 2, 4. And 4, 5. Okay, what did that form? It also formed a line, because when you do the inverse of a function, you will still get the same type of function. If it was linear, it's still going to be linear. It's just in a different place on the graph. Okay, so the red line is the original function, 2x minus 6. The blue line is the inverse of that function. Okay, now I want you to take a couple of minutes and try the next problem by yourself. Alright, now number 2. Do you think when we graph number 2, we're going to still get a line?
No.
Why not? Okay, when it's squared, it's known as a what kind of function? What kind of function? Quadratic, and it makes a parabola. Okay, so let's go ahead and plug in our x values. What is 0 squared minus 2? -2. What is -1 squared minus 2? All of you who said -3, did you type parentheses around the -1? You have to. Okay, because let me show you something. Those of you who got -3, this is what you did. You typed in -1 squared minus 2. Well, your calculator doesn't know to square the negative sign because you didn't put it in parentheses. But we all know that -1 squared means -1 times -1. A negative times a negative would make a +1 minus 2, which is -1. You have to put parentheses around any number you're plugging in for x. Okay, what about when we plug in a +1? You will also get -1, because think about it. It doesn't matter whether you plug in a -1 and square it or a +1 and square it. You get the same answer, because -1 times -1 is the same thing as +1 times +1, isn't it? Because those two negatives become a positive. What about when you plug in a -2 and square it? What do you get? 2, because you get 4 minus 2, which is 2. And then what about when you plug in a +2 squared minus 2? 2. Okay, so now let's plot these points and see what the graph looks like. 0, -2. How would I plot that? Down 2. -1, -1. +1, -1. Right 1, down 1. -2, +2. Left 2, up 2. And then +2, +2. So see how knowing what the graph is going to make before you even start graphing it will kind of help you know if you're putting the points in the right places. Okay, it makes a parabola. Now, is that parabola a function? Does it pass the vertical line test? If I draw a vertical line, look, if I draw a vertical line through that parabola, does it hit the function more than once? No, so it's a function. Okay? To pass the vertical line test means the vertical line only hits it once. If it passes, it is a function. Okay, now we are going to graph the inverse of that parabola and see if it's still a function. So what do I have to do to graph the inverse of it? Switch the x's and y's, so it would be -2, 0, -1, -1, -1, +1, 2, -2, and 2, +2. And now we're going to plot those 5 points. How do I plot negative 2, 0? Just go left 2, because remember the negative 2 is in the x, so we have to go on the x-axis to negative 2. What about negative 1, negative 1? Left 1, down 1, okay? What about negative 1, positive 1? Left 1, up 1. Okay, what about 2, negative 2? Correct. And then 2, 2. Right, 2, up 2. So, did it still form a parabola? Yes, it just turned it on its side. So, is the inverse a function as well? If I draw a vertical line through my inverse, does it pass the test? No, it crosses it once and then twice. If it passes more than once, it is not a function. Now, there's a way to tell whether it's a function or not without even having a graph to look at. You probably learned this in 9th grade. Each input can only have one output. Now, it's easier for y'all to understand it a different way. So you may remember this from 9th grade. I'm going to call my x values boys, and my y values are going to be the girls. Okay, now, for a equation, for it to be a function, the boys cannot cheat. Okay, in math world, it's okay for the girls to cheat, but only in math world. But the boys cannot cheat. Okay, so let's look. This boy, his name is 0. He went out on a date with girl named negative 2. This boy, negative 1, took out girl negative 1. Boy, positive 1, took out girl negative 1. Boy, negative 2, took out girl 2. And boy 2 took out girl 2. Was there any cheating? Right. Only the girls cheated, which is okay in math world. But since no boys cheated, it is a function. Shh. Pay attention, please. Now look over here at this table, the inverse table. Did any boys cheat over here? Yes, this negative 1, on Friday night, he took out girl negative 1, and on Saturday night, he took out her twin. I know. But she's the good twin. He took out the bad twin the first night, so you know. Okay, also, boy 2 is a cheater. He did the same thing. So that's why this is not a function, because each input did not have a unique output. Each boy did not have one and only one girlfriend. Okay? So now I want you to try number 3. Graph the original function, graph the inverse, and see if it's a function. What did you get when you plugged in a 0? Okay, what about 1? Negative 1, 2, and negative 2. Okay. Now to plot it, 0, 0 is right here. 1, negative 2, negative 1, negative 2, 2, negative 8. It's negative 8 right there on it. And then on the other side, since it's a parabola, it's kind of easy to graph these. Okay, now, why in the world is that parabola upside down? Because it's a negative parabola. Okay, so now when we do the inverse, what will my table look like? Right? Okay, so 0, 0, negative 2, positive 1, negative 2, negative 1. Negative 8, positive 2, and negative 8, negative 2. Okay, so was the original one a function?
Yes.
Yes, it passes the vertical line test, and you see that there's no boys that cheat. There are no x values that have multiple y values. Okay? What about your inverse? Is it a function still? No, because we can see by the graph that it would fail the vertical line test. It crosses more than once, and we can see by the table that we have some cheaters. Okay? Okay, now, do you notice anything else?
It's sideways.
Okay, well this one opened up and it turned sideways to the right. When it opened down, it turned sideways to the left, the negative direction. Does that make sense? Okay, let me say that again because some of you are talking and I don't think you heard it. See how when it's positive it opens up? The inverse opens to the right, which is still the positive x-axis. Down here when it opens down, because it's negative, the inverse opens to the left, which is the negative x-axis. Okay, go to the next page. We're going to skip number 4 for just a second. Let's go to number 5. We'll go back to it. Alright, number 5 says, given g equals the following ordered pairs, find g to the negative 1. What does that mean, g to the negative 1? The inverse. Remember back when we were doing matrices in Unit 1 and you would raise it to the negative 1? The whole matrix you would raise to the negative 1 to find the inverse of that matrix? That means find the inverse, guys. This is notation for inverse. So, g to the negative 1, which means the inverse of g, would look like what? 2, 1. All you do is flip-flop the x's and y's. Oops, I didn't mean to do that. Oops, not that either. Hold on. Okay, there we go. Okay, so all you're going to do is switch the x and the y because we're just trying to find the inverse. So 2, 1 would be the first point. What would be the next point? And then the next? Okay. And? Right. Okay, so there's g inverse. All you do is switch the x's and the y's. Okay, number 6. Which graph below is the inverse of this graph? Okay, so they gave you a graph over here, and they want to know which one out of A through E is the inverse of that graph. So what do you think we could do to figure that out? Okay, we could figure out some points on our original graph. Like if we plot 3 points, maybe there, there, and there. It could be any points you wanted, but I'll just plot those 3. Let's identify the coordinates of those 3 points. What are the coordinates of this top left point? This one? Negative 3, positive 2. Okay, what are the coordinates of this point? Right, and then this point? 3, 0. Okay, so those points all belong to this graph. Now I'm going to look at the inverse of each of those points. What would the inverse of negative 3, 2 be? Okay, what about 0, negative 1? And what about 3, 0? Okay, so now we're trying to figure out which graph down here do these points belong to. So let's look at A. If I plot that first point, 2, negative 3, right 2, down 1, 2, 3. Is that on that graph? No, so A is definitely not the inverse of this. If I go to B and plot right 2, down 3, did I fall on the graph? Nope. If I go to C and I go right 2, down 3, am I on the graph? Okay, so that one's working so far. Negative 1, 0. Is that on that graph? Yes. And 0, 3? Yes. 0, 3 means just go up 3, and that lands on the graph. So C is the inverse of the original graph. And then you can quickly check D and E. If you go right 2, down 3 on either one of those, it does not land on the graph. So we know those are wrong. Okay? Alright, now I'm going to give you a couple of minutes to try 4. Okay, what did y'all get when you plugged negative 2 in that one? Negative 5. Okay, what about negative 1? 0? 1? And 2? Okay, so when I graph this, I'll go left 2, down 5. Negative 1, positive 2 is left 1, up 2. 0, 3 is just up 3. 1, 4 is right 1, up 4. And then 2, 11, is it just 1 off the graph? Okay, now, this isn't a straight line and it's not a parabola. Why? It's a cubic function, which kind of looks like a snake. Oops, and it's very hard for me to do. Okay, so now we're going to graph the inverse of that. So what do I need to do first? switch the x's and the y's, so it would be -5, -2, 2, -1, 3, 0, 4, 1, and 11, 2. So left 5, down 2, 2, -1, 3, 0, 4, 1, and then 11, 2. Okay, so still the same type of function, a cubic function, which makes a snake-looking graph, but the inverse looks like that. Now, are both the original and the inverse functions? Yes, they would both pass the vertical line test. Now, some of you may be wondering, like, say you drew your vertical line right here. Right there, it appears to cross it more than one time, right? But it's only because I can't draw it perfectly. When you're doing that cubic function, shouldn't it slowly go farther and farther out each time? And so therefore the vertical line would never cross it twice. But I just obviously can't draw it perfect every time. Okay, we are done. Don't forget 10 squared tomorrow. Work on your review sheet for the test tonight. And the test is Friday.